Now let's talk about adding and subtracting with different exponents. When adding or subtracting scientific expressions with different exponents, you first need to rewrite them so they have the same exponent. For example, here we have 3 times 10 to the 4th plus 5 times 10 cubed. In this case, the expressions have different exponents, 4 and 3. So it would be easier to convert 10 to the 3rd to 10 to the 4th. So you need to move the decimal point one place to the left. So the new coefficient becomes 0.5. And since you move the decimal point to the left, which decreases the value by a factor of 10, you need to offset that by increasing the value of the exponent by 1. So that becomes 10 to the 4th. Now that gives you 3 times 10 to the 4th plus 5/10 times 10 to the 4th. And now you have the same exponent. So you can add the coefficients, which gives you 3 plus 5/10 times 10 to the 4th. And 3 plus 5/10 is 3.5 times 10 to the 4th power. And since 3.5 is greater than or equal to 1 but less than 10, this is the final answer. Next you have 8 times 10 to the 6th power minus 2 times 10 to the 5th power. And once again you have different exponents. And in this case it would be easier to convert the 5th power to a 6th power. So once again you need to move the decimal point one place to the left. So the new coefficient becomes 0.2. And since you moved it to the left, which is decreasing it by a factor of 10, you need to offset that by adding 1 to the exponent. So that becomes 10 to the 6th power. And now you have the same exponent. So that gives you 8 times 10 to the 6th power minus 0.2 times 10 to the 6th power, which gives you 8 minus 0.2 times 10 to the 6th power. And 8 minus 0.2 is 7.8 times 10 to the 6th power. And since 7 is greater than or equal to 1 but less than 10, this is the final answer. Now follow along as I solve these problems. Here I have 4.5 times 10 to the 4th plus 3.7 times 10 cubed. In this case, I have different exponents, so I need to make them have the same exponent. And in this case, I can change the 10 cubed to 10 to the 4th by moving the decimal point one place to the left. So the new coefficient becomes 0.37. And since I moved it to the left, I can add 1 to the exponent. So that becomes 10 to the 4th. And now I have the same exponents. So I can go ahead and add the coefficients, which are 4.5 and 0.37 times 10 to the 4th power. And 4.5 plus 0.37 is 4.87 times 10 to the 4th. And that's my final answer. Next I have 6.9 times 10 to the 8th power minus 2.5 times 10 to the 7th power. And once again, I have different exponents, so I need to make them have the same exponent. So I can move the decimal point in the second number one space to the left, which gives me the coefficient 0.25. And since I moved the decimal point to the left one space, I need to add 1 to the exponent. So the 10 to the 7th becomes 10 to the 8th. And now I have the same exponent. So I can go ahead and subtract the coefficients, which is 6.9 minus 0.25 times 10 to the 8th power. And 6.9 minus 0.25 is 6.65 times 10 to the 8th power. And that's my final answer. Now it's your turn to practice. Pause the video and solve the problems. And when you found your answers, click play. Here you have 2.8 times 10 to the 9th power plus 6.5 times 10 to the 8th power. And here the exponents are different, so you need to make them the same. And it would be easier to convert 10 to the 8th power to 10 to the 9th power by moving the decimal point one place to the left. So the new coefficient becomes 0.65 times 10 to the 9th power. Because when you move the decimal point one place to the left, you need to increase the exponent by 1. And now the exponents are the same. So you can go ahead and add the coefficients, which gives you 2.8 plus 0.65 times 10 to the 9th power. And 2.8 plus 0.65 equals 3.45 times 10 to the 9th power. And that's the final answer. Next you have 9.3 times 10 to the 5th power minus 1.8 times 10 to the 4th power. Once again, you have different exponents, so you need to make them the same. And in this case, it would be easier to convert 10 to the 4th to 10 to the 5th by moving the decimal point one place to the left. So the new coefficient becomes 0.18 times 10 to the 5th. And now the exponents are the same. So go ahead and subtract the coefficients. So that gives you 9.3 minus 0.18 times 10 to the 5th power. And 9.3 minus 0.18 is 9.12 times 10 to the 5th power. And that's the final answer. Now it's time for more practice. An astronomer is analyzing the sizes of two different stars. The radius of the first star is measured as 3.5 times 10 to the 6th kilometers, while the radius of the second star is measured as 2.1 times 10 to the 7th kilometers. If they want to find the difference in radii between the two stars, what is the result? In this case, you want to find the difference, which means you need to subtract. And you need to subtract the smaller number from the bigger number. And in this case, 3.5 times 10 to the 6th is smaller than 2.1 times 10 to the 7th, because 10 to the 6th is a whole exponent smaller than 10 to the 7th. So to rewrite that, you would write 2.1 times 10 to the 7th minus 3.5 times 10 to the 6th. And here you have different exponents, so you need to convert them to the same exponent. And in this case, it would be easier to convert the second number from 10 to the 6th to 10 to the 7th by moving the decimal point one place to the left. So the new coefficient becomes 0.35 times 10 to the 7th. And now you have the same exponents, so go ahead and subtract the coefficients, which gives you 2.1 minus 0.35 times 10 to the 7th power. And 2.1 minus 0.35 is 1.75 times 10 to the 7th power. And make sure to add the units, which is kilometers. So the difference in the radii between the two stars is 1.75 times 10 to the 7th kilometers. Hey, it's Nicholas, creator of Mathemy, and if you like this video and want to take your math skills to the next level, check out my online course, Pre-Algebra Made Easy. Whether you're preparing for algebra, geometry, or a standardized test like the GED, ASVAB, or GRE, this course is for you. Dive into interactive videos where you'll shadow me through problems, then take the reins to practice solo. Worried about making mistakes? Don't be. I'll walk you through each solution, making sure you understand every step. But it doesn't stop there. Quizzes, practice activities, and detailed answer keys will solidify your understanding. Cap it off with section tests and an end-of-course exam to showcase your new skills. Mastering pre-algebra is the key to future success in math and beyond. Click on the link in the description below to enroll now and start your journey to math mastery. I'll see you there.